The diagram shows 5 energy levels of hydrogen atom. Which one of the electron transitions will give rise to a spectral line in the ultraviolet part of the electromagnetic spectrum? So when an electron goes to the lower energy level, a photon is emitted, and we need the energy of this photon to be in the ultraviolet region, and let's estimate energy required to be in the ultraviolet part of the electromagnetic spectrum in electron volts, and formula is that energy is h c over lambda, or h frequency, and I know that for ultraviolet it's about 400 nanometers, or maybe 450, and less if we say about wavelengths up to X rays, it's about 1 nanometer or 0.1 nanometer. Let's consider 400 and 1 nanometer to find the bounds to be in to be ultraviolet. So H, it's what, 6 point something, 6.6 times 10 to negative 34, 3 times 10 to 8, 67, or let's take 6.7, and 400, so 4 times 10 to negative 7, and it will be in joules, and to get in electron volts we divide by the elementary charge, times 10 to negative 19. And about powers, you can see negative 34 plus 15, and it becomes 0, so it becomes just 6.7 times 3 divided by 4 and divided by 1.6, it's 3 point something, so it's about 3 electron volts, and it's when we take 400 nanometers, and we can decrease lambda up to, or actually we can decrease lambda to 1 or to 0.1, so by 400 times. And if you decrease lambda by 400 times, energy increases by 400 times. So it may be what, 1200 electron volts, or actually maybe 10 times larger if you consider 0.1 nanometer or something like that. So or actually we can consider 450 or 500, so it can be a bit less than 3, something like that. So let's consider possible transitions, and for A it's 0.85 electron volts, definitely it's much less than 3, so definitely not A. B, it's 1.5, it seems it's less than required, and B 1.5, and C it's about 0.7 or something like that. And you can see that it's about what, about 13. Yes, it seems to be correct, because if you consider a bit larger lambda, it will be a bit less, maybe 2.5 or something like that, and it's not enough to be 0.85 or to be 1.5 or to be, here it's about 75 or 65 or something like that, but definitely it's less than required. And this is 13, about 13, and definitely it's greater than this and less than this, so it's possible, and it's the required transition to be in the ultraviolet part of the electromagnetic spectrum. And that's all for this question.